This is the GCNA level Mathematics 2020 Paper 2 question number 11. Starting with part A. A, B and C are points on the circumference of a circle with center O. TA and TB are tangents to the circle. At angle OTA is 32 degrees. And we have to complete these three statements by calculating the size of each angle and giving a reason for each of them. Now we will look at the diagram over here. Now you are told that TA and TB, they are actually tangents to the circle. This is this one and this one. So I can actually say OAT. I can say that OAT is actually 90 degrees. And the reason for which is tangent TA is perpendicular to the radius. To radius OA. Now find angle AOB. Okay, AOB over here. Okay, now in this case, how exactly do I find the angle AOB? Now I do want to mention that there's actually another property that you learn in this thing called circle properties. So they're actually tangents from an external point T. And these two tangents, they are actually the same in terms of length and angles. So in other words, I can say that these two triangles are actually congruent. They have a common length over here, radius over here, and then the hypotenuse. This is a common side. And then these two are actually of the same length. So these are properties of a tangent from an external point. So I can find the angle AOT, 180 minus 90 minus 32. Take a calculator. So this one is 58 degrees. Now based on the deduction that these two triangles are congruent, am I right to say that this is also 32 degrees? And because TB is a tangent, I can say that this one's also 90 degrees. If this is the case, isn't this angle also 58 degrees? So in other words, AOB 58 plus 58. Angle AOB is actually 116 degrees. Angle AOB 116 degrees. Reason because of tangents from external point T, where in this case AT is BT. They are the same length over here. Then they have a common length over here. OT is the common length. And actually OA is equal to OB. That's why I said that these two triangles are actually congruent. Okay, now we go to angle ACB here. How do I find angle ACB? Notice that ACB is an angle at the circumference. AOB is an angle at the center. What you learn in circle properties is angle at the center is 2 times the angle at the circumference. So angle ACB in this case, simply just 116 divided by 2. So you get 58 degrees. Reason being, angle at the center O is actually 2 times the angle at the circumference. And this is how you approach question 11a. Moving on to question 11b. In this case, we have a triangle. The triangle here. Now, in this case, at first hindsight, it looks like a right angle triangle. But because there are no right angles denoted on the diagram, we cannot assume that QPR is a right angle triangle. Now, they actually want you to find angle PQR in part 1. This is 11b, part 1. So how do I find angle PQR? this angle PQR. I have three sides over here, and I have an angle between these two sides. So in this case, can I apply the cosine rule? So by the cosine rule, actually cosine angle PQR, cosine angle PQR, simply just 6.5 square plus 12.3 square minus 8.2 square over 2 times of 6.5, 12.3. To find the angle, simply take cosine inverse of this whole thing. Simply take cosine inverse of this entire thing, and you type it into your calculator. Please ensure that your calculator should be in degree mode, unless the question states that they want the answer in radian. But in this case, we will take it as is in degrees. So cosine inverse 6.5 square plus 12.3 square minus 8.2 square, 2 times of 6.5, oops, 12.3, close bracket. In this case, this is the angle that you get. Do note that for final answer, angles will always be left in 1 dp. So PQR in this case 37.8 degrees. 1 dp. Yeah, so angle PQR 37.8 degrees. Okay, part 2. At P, there's a vertical post of height 3.7 meters. Calculate the angle of elevation of the top of the post from R. Okay, so we know that at point P, vertical height of 3.7 meters. So post, you can take this as the post, and then this is 3.7 meters, and this is above P. And we want to calculate the angle of elevation from R. Angle of elevation usually will involve dua, ka, so. Similarly for angle of depression. Angle of depression as well is dua, ka, so. I know that PR from the diagram, it is 8.2. In this question, all length measurements are actually given in meters. Now I will let the angle of elevation here, let it be theta. So angle of elevation is given by theta. So I can use my tangent ratio. Tangent theta 3.7 over 8.2. To find angle is tangent inverse of whatever is over here. Take our calculator. Tangent inverse 3.7, 0.2. Remember, angle, final answer always in 1 dp. So eventually my value of theta would be 24.3 degrees 1 dp. So angle of elevation in this case is 24.3 degrees. And this is how you approach question 11 of the 2020 paper 2.